So let us see something about ellipse generation. So here we can see what a ellipse is like. You can define an ellipse as a set of points such that the sum of the distances from the two foci, okay, is always constant. Like here there are two foci, f1 and f2, and suppose a p point is on the circumference. So the distance from the first foci, it is d1, and the second foci d2. Sum of d1 and d2, suppose if I am writing d1 plus d2 is always equal to some constant. Okay. So keeping this thing in mind, definitely this f1 will be having some coordinate, f2 will have some coordinate. Using these coordinate values in terms of x1 y1 and x2 y2, we can write it as an equation. Okay, this equation will look something like this. Suppose it is f1, f1 is x1 y1 and f2 is x2 y2. Okay, considering these 2 points as foci, what you can say is any new point xy can be treated as like this: under root x minus x1 square plus y minus y1 square. Okay, plus this distance x minus x2 square plus y minus y2 square. Okay, this sum will always be constant. Okay, so this information can be used for generating ellipse. How? Right? Okay, let us start with understanding that this was your term, and if you perform the square on both of the side, okay, and whatever the radicals are there, you can isolate them and then square them again, and some of the things can be done, and then you will get an equation, right, which will look something like a coefficient x square plus coefficient y square plus coefficient xy plus dx plus ey plus f is equal to 0. Okay, okay, let me write like this. So this is something you will get after you perform certain simplification on this particular equation. Now you see this a, b, c, d, these values are coefficients. Okay, this can be found or evaluated based on the focal coordinates. Okay, now in an image there is something called major and minor axis. Okay, whenever image I am saying ellipse, this is your ellipse, so this longer axis is called as major axis. Okay, and this smaller axis is called as minor axis. Okay, so the major axis is the straight line segment which is extending from one side of the ellipse to the other, which also passes through the two foci. However, this minor axis passes through the center. Definitely it is also passing through center, but it passes through the center and perpendicular to the major axis, right? Okay. So now, what is the center? Center will be in between these two foci. Okay. Now, what can we do now to find out the coordinate values for the circumference? Okay. On the circumference, we want to find these pixel values. So now, suppose whatever arbitrary orientation is there for this particular ellipse, we understand that there are two foci, right? So we need these two foci and any one point on the circumference. So now what will happen? You will get this thing x1 y1 and x2 y2 as well as some xy, so that you can calculate the distance d1 and d2. Using this, you will be aware of the constant value. Okay. So now you are aware that the sum should be equal to this particular constant value, and then after that you can use this particular equation to find out the values. Okay. So but still you can understand that this may be a little difficult thing, little more computation will be required, right? Now if we are aware of this major axis as well as the minor axis, then something can be simplified. Okay. How it can be simplified? Suppose this is your ellipse. In this ellipse, this is your center. You understand this is your major axis. On this major axis, let me say this is the portion. We are calling it Rx, radius in the major axis. Let me call it Ry. Okay, radius in the y direction. We should keep it as x and y only, because some of the times when the ellipse will be like this, then also we will call it as Rx and this we will call it as Ry. So let us consider that this is in x direction, radius in x direction and radius in y direction. And what is this? This is your center. Suppose xc yc. Let me keep it as xc yc. Having this information, now what do you want? See, equation of ellipse, which you have already seen here, or maybe we have also seen in circle, but let it be. We are coming to the ellipse. Here you can write it as any point x minus the x center upon r in x direction. Okay, a square of this thing plus the same thing in y direction, y minus yc upon the radius in y direction, a square of this thing. This summation will be equal to 1. This is a equation for your ellipse. Now you can use this equation. If at all you are aware of your major and minor axis, then you can use this equation with the center and you can find out the value of your corresponding coordinates. Not only this, another one more option will be the polar coordinates. Polar coordinates are what? Same thing. X is x center plus the radius in x direction into cos theta. Okay, and y is equal to yc plus radius in y direction and sin theta. You can use this option also to find out all the coordinates. So these are the possibilities. Here again you will see that you can use the symmetric property as you used in the circle. In the circle actually it was all the octants were symmetrical. Here the octants are not symmetrical. Okay. In ellipse you cannot guarantee that the octants will be symmetrical, but still this particular, what we call it, quadrants are symmetrical. So you can find this thing, pixels in one quadrant, and you can use them in other quadrants as well. Okay. But still you understand that calculation of either square values, root under square values, whatever, and trigonometric values will be more computable. Is there any way like we did for line algorithm or for circle algorithm? Is there some way? Yes, it may be. We can go for, we will call it midpoint ellipse algorithm. Okay. Midpoint ellipse algorithm. So we will see this midpoint ellipse algorithm in the next video. For now, thank you.